Alright, so hi everybody. As Chris mentioned, I'm a senior software engineer at TRS Systems. I've been at TRS Systems for the past 4 years, and I've been involved in application development for a wide range of projects related to hydraulics, agriculture, and IoT integration. Before we jump into the topic of using AI to code within the CODESYS IDE, I want to introduce TRS Systems. TRS Systems is a Canadian company. We specialize in providing custom control system solutions and cloud-based solutions for IoT and Industry 4.0 integration. We are proud to be CODESYS system partners in Canada. Right. So I'm just going to reshare with some sound here. So here's just a quick video outlining some of the services that TRS provides.
Are you a custom equipment manufacturer looking to integrate IoT-based remote monitoring to your equipment? Or does your equipment use CAN-bus or J1939-based control system that could benefit from cloud-enabled remote monitoring and predictive maintenance? If yes, then we have got you covered. At TRS Systems, we understand that your business is different. And to collect the right data and turn it into profit, you need IoT solutions tailored to your business model. With our custom IoT cloud solutions, we can provide you with a dedicated cloud platform for your unique IoT needs and help your business achieve digital transformation. We can help you achieve one or all the IoT use cases that apply to your business. So whether you're a custom equipment manufacturer, a systems integrator, or your business relies on parts or maintenance of an industrial plant, we've got your IoT digital transformation covered. Contact us today to launch your business into cloud. Stay tuned to find out about our comprehensive 4-step IoT digital transformation process.
All right. I won't need to share sound again, Chris. So if you want to turn it back to multi-share, you feel free to do that.
Fine, thanks.
So yeah, as the video described there, some of the services we provide, one being advanced control system integration for electro-hydraulic systems, including the programming and wire harness design. Another is the industrial Internet of Things, leveraging ImmerCloud. And ImmerCloud is basically a custom dashboard for viewing and analyzing data. And on top of that, we also offer basic and advanced CODESYS training. Some of our use cases include the control systems for mobile industrial equipment like agricultural feed mixers, cement trucks, and excavators. Another use case is asset management using cloud connectivity, which also includes predictive maintenance. So here's some of the hardware companies we've worked with while utilizing CODESYS. As you can see, we're experienced with many different kinds of ECUs, and working with so many has given us a broad view of the hardware landscape. So now that I have the introductions out of the way, we can move on to the topic of this tech talk, which is using AI to code within the CODESYS IDE. More specifically, what I mean by that is essentially leveraging large language models and Iron Python in the CODESYS IDE to automate object-oriented programming. I'm going to show you a couple tools that TRS System uses to aid our development within CODESYS. I'm going to go over some of the highlights from last year with the overall goal of providing you with an idea of what is possible with the combination of LLMs and Iron Python in the CODESYS IDE. So first example I have here, I guess it's a bit of a trivial example, but what I want to demonstrate is that we were able to use this chat interface to navigate a CODESYS project and add a instantiated function block into a PRG. So on the screen here, we see that we have a single coil function block, and below that is a PRG called PRG auger. So I'm telling this this chat interface to focus on this auger PRG. And now I'm saying call this single coil function block and set the jump to current to 450 milliamps and set the max current to 1.1 amps. Some interesting feature that I guess this also demonstrates is that you can set up the LLM to ask follow-up questions and basically have a required set of information that it requires before it can move forward. So in this case, I only specify the jump to current and the max current, but I've set it up so that it needs me to also give it the proportional integral and derivative constants for the PID loop. So you can see that it is it's asking for that data before it can continue. Oops. Sorry. So I tell it that I'm going to set the I constant to 5 and the other PID constants will be 0. And I'm also using this informal language here at the end. I'm saying change the jump to current to half an amp. So this was kind of a demonstration on what it can do here. So it successfully does that. It takes my correction using an informal kind of way of speaking, and you can see down here that it successfully calls the single coil function block with a jump to current of 500 milliamps, max current of 1100 milliamps, and an I constant of 5 with the others being 0. This next example is basically me giving this chat interface some info. And I think the important thing to realize here is this info could be from any number of documents that you end up with when developing a project, whether it be from customers or emails or project proposals. This is kind of I guess, a proof of concept that you can take information from these sources and successfully automate some of the more routine coding tasks here. So I'm telling it to focus on this DUTs folder because that's where I want to place this enumeration that I'm going to generate. So it says, so I instruct it to create an enumeration for mixer states, and it successfully does that. And you can also see that I've behind the scenes, I've kind of given it, oops, sorry about that. Behind the scenes, I've given it a instruction to name, to follow a naming convention where the type, the POU type precedes the name of the POU. So it's actually following that that naming convention pretty well. It's saying enumeration mixer states, and it's put that in the DUTs folder. So I've told it to focus on this, and now I've basically pasted some info about what I want the enumeration to do. So I tell it to populate the enumeration with states described here. I also tell it to keep the line length below 80 characters. I'm saying this mixing device has multiple states. The first state is off. When in off state, it is recommended to not apply any PWM to the coils. The second state is idle. The mixing device must idle until the temperature has reached 90 degrees Celsius. The third state is called active. In this state, the mixing device is responsive. Note that if the mixing device reaches a temperature of 140 degrees Celsius and an oil pressure exceeding 150 kilopascals, the mixing device must enter the regen state. So I'm giving it a lot of information there, and I think there's one more state that I just need to wait for this video to scroll down to. Yeah. So the last state is called regen. In this state, the mixing device will be torque limited to 50% of the maximum torque. So the way I kind of envision this is this could come from an email or something. And I wouldn't say this chat interface is the most efficient way to accomplish this, but I'm gonna get to what we're using now a bit later in this talk. But as a proof of concept, I think you can see that this succeeds. It basically fills in that enumeration with the states, and it comments with the respective info related to each of those states. Another example here is interacting with the CODESYS field buses. We were able to use this this chat technology and basically hook it up to the Open PLC XML functionality of CODESYS. So it's basically taking some information about some CAN channels that we want to add to the CODESYS project, and through editing some PLC open XMLs, it's able to add those into the project, and it does transfer this information into those XMLs successfully and reliably. So here it says we need 2 CAN channels. Channel 0 is main controls, channel 1 is aux controls. Channel 0 has 3 ECUs, channel 1 has 1 ECU. Channel 0 has a baud rate of 500,000. Channel 1 has a baud rate of 250,000. The ECUs on channel 0 have addresses 100, 101, and 105. They represent engine temperature, pressure A, pressure B, and pressure B respectively. ECU on channel 1 has address 200. It represents washer fluid level, and all ECUs on channel 0 have a watchdog timeout of 1,000 milliseconds. So I'm taking that email and I'm pasting it into this this chat interface. And then you're gonna see the CAN bus controls being added here. And I will go through each of these and verify that the info is what we wanted. So for the CAN bus 0, the main controls, the baud rate is 500 kilobits per second. Engine temperature is the address is 100 and the watchdog is 1,000 milliseconds. Pressure A, preferred address is 101. Pressure B, preferred address is 105. They both have the correct watchdog time. For the second network, it has a baud rate of 250 kilobits per second, and the preferred address for that washer fluid is 200 and 1,000 milliseconds in the watchdog. So I'm just going to make a change, and I'm going to just demonstrate that it can it does have kind of a finite or a fine grain control over these settings. So I'm saying the engine temperature should have a timeout of 200 a watchdog timeout of 200 milliseconds, and the aux controls have watchdog disabled. So after deleting those old functions, I send it this new info, and I'll demonstrate that it's still correct. So yeah, the watchdog time is changed to 200 milliseconds for the engine temperature. Pressure A and pressure B, those stay as 1,000. And then in the aux controls, we can see that the watchdog is just disabled. So yeah, some examples. That one I think can be really useful and for templating. So I guess what we've done over the past year is basically move to a more generalized interface. So this chat interface, I think it has a lot of benefits for training and looking up documentation, but and also filling in a lot of templating as well. But like I said earlier in the presentation, TRS deals with a lot of different types of hardware, and they all kind of use different CODESYS versions, different libraries, you know, different hardware, different ways of adding these field buses and stuff like that. So what we've done over the past years is make a bit of a more generalized tool, and this is kind of what we use most commonly. And yeah, it's written in IronPython just like that chat interface, and you launch it right from CODESYS, and it has access to all of your project, all of the POUs and Fieldbus and everything like that. And you can see in this video here, it's just you're able to just click on it, the icon in the toolbar, and it brings up this this prompt designer, I guess you could call it. So using this this GPT prompter, I'm going to I'm gonna show a quick demo of it taking this these comments here, this basically pseudocode, and um, and it will create the code that goes along with this with these comments. So here, this function block is just a mixer. It uses a PID loop. Basically, there are different states. It has the feedback milliamps, the PID constants, and then it outputs a PWM value, which is going to be sent to the hardware PWM output, and also an error. And you can see that inside of the vars, there are two instances of function blocks within this function block. So it has a basically a linear transform called duty trafo, which is transform, and a PID instance as well. In the comments here, I'm telling it to calculate the target current from the duty current if the state is in regen, and this is kind of a bit of a throwback to that enumeration. If the state is in regen, activate float mode during duty current calculation. If the state is not running in regen, or if there are any errors present, set the PID set point to 0. Use PID to calculate PWM, manage error handling for the error output. If PID overflow, then set PWM to 0. So I'll explain more about what's going on in this tool in the next few slides, but I'm basically I'm basically telling this tool to include all of the structured text within this function block mixer 1, and I'm also telling it to include context. And what that is it's gonna search through this this variable list, and if it comes across any POUs that are instantiated within the variable list, it's going to include the code from those POUs into the into the LLM prompt as well. So basically, that's just giving the the LLM is the best amount of context that it needs to accurately generate a response. So basically, I'm adding some code tags around this because that's where I want the tool to insert this code. So we send it, it's generating a response. The response pops up here. I manually copy it and replace it into this into the structured text. And as you can see, it does a pretty good job of filling out that code. So it successfully uses that transformation because it was provided with the structured text from that POU. It knows the correct inputs and outputs, and I guess the way these neural net technologies and these large language models work is it can connect enough dots that it knows that, hey, it assumes that the duty current input from this POU is going to be connected to the duty current for the transformation. So it does the transformation successfully. It deals with these enumeration states successfully. it calls the PID and it kind of deals with this error, maybe not in the most graceful way, but it does it gets you about 70%, 80% of the way there, and it definitely takes care of some of the more monotonous typing. And I think that has a lot of benefits for overall code quality because it's going to essentially give you more time to do unit testing, to make sure your documentation is as good as it can be, and things like that. So now I'm gonna just walk through the the parts of this GPT prompter. So first thing is this configs row, and this is hooked up to the OpenAI API, so there's a lot of different models you can choose from. So that's why I include this. You can choose which model you want to interact with. And from my experience, some models do better with structured text than others. A lot of times they update these models and something changes and it doesn't really react how you want it to anymore. So you can go back to an older model that works better for you. I also include this frequency penalty and temperature. Those are basically just settings that have a bit of an effect on the response. So frequency penalty, if it's a higher frequency penalty, the LLM is going to um, not repeat words so much. And this temperature setting is it's basically the randomness that is given to the LLM during its generation. So if you have a temperature of 0, it's supposed to be near deterministic, where you're going to get a pretty set number of responses, and it's never really going to deviate from maybe, from my experience, maybe 2 or 3 different types of responses. And then this last input here is just the number of responses you want to generate. So sometimes it's a bit quicker to generate maybe 3 responses and then move forward with the best one. The system message is the general instructions that you're giving to the AI model. And it's our default is you will be editing and or adding code inside the code tags. You must write in IEC 61131-3 compliant structured text. Only respond with the structured text code. Make sure to include comments in your code. You will be given contextually relevant structured text code and variables. So yeah, that's the general way that the AI responds. This third and fourth row, the third row contains a drop-down menu that allows the user to select the POU and include that will be included along with the user message. This is really where the tool makes your life more convenient because it goes through your your project and adds this structured text code so that you don't have to manually go and copy and paste it into a chat prompt like ChatGPT or something like that. And then last is the direct message that you want the AI to respond to. So yeah, here's just an example of the drop down there. It has all the different function blocks and POUs within the project. And just a bit of a visualization of how this tool basically shapes the prompts. It's first is the system message, and then it includes all of that relevant function block info. So right here is you have a function block A, and it includes function blocks B or function block B and C within it. So there is a comment added that says below is relevant info. Then it has the function block B structured text, and then again, below is relevant info, the function block C structured text. Then it's the final user message, and finally the function block A structured text is the last thing that is in the prompt. Here is just a quick another quick example there, basically showing that you can also take the text from the messages feedback portion of CODESYS and cycle it back to the AI, and it can basically try to fix whatever errors there are. So yeah, just wrapping up this talk. I think over the past year or so, what we've kind of demonstrated within TRS Systems is that there's a lot of these puzzle pieces that we've kind of developed where the AI can interact with the CODESYS project and make your life quite a bit easier. Like it can create the POUs and DUTs, it can instantiate and call POUs, can template those communication networks, can write and edit code, and it can also correct code based on compiler feedback. So there's a lot of things that LLMs succeed at, like editing and refactoring the code, explaining the code, adding context, creating unit tests and state structures from CSV files. I mean, that could also be done with scripting, but these LLMs along with Iron Python, it really does give you a lot of opportunities to make coding a lot easier. And I think we see that just with how these AI models are kind of integrating with everything now. Like I know Apple with Siri, their kind of goal is they want you to be able to talk to Siri and it can edit your calendar and stuff like that. I think there's a lot of potential for something like that in CODESYS as well. And I think basically there's a lot of templating that can be done from a lot of the project communications that already exist. I think that's a main one, and I think using Iron Python and that generalized tool can really help make a lot of the more monotonous aspects of coding. I think it can really streamline that. And then I think it basically allows you to use your time to raise the overall code quality with documentation and unit testing, which I think a lot of times kind of falls by the wayside. So yeah, if anyone has any questions about that, please feel free to reach out to us, and we'd love to discuss with you about what kind of possibilities the AI models in Iron Python have in CODESYS, and especially in a closed boundary system. I think there's a lot of interesting things that could be done. So thank you very much.